Hey everybody, what's up? What is cracking? What's happening? What's going on? So yeah. Hey Jacqueline. Hey Dejet. I'm gonna let everybody kind of funnel in here. It was kind of a impromptu kind of thing again tonight. And what's up? AB and him. What's up? 5 for 5. Okay, cool. Cool. Let's see if anybody else files in. I realized that what time is it? Yeah, it's like 10 after 10. East on the East Coast, by the way. Hey, Seven, Brandon, and Julie, what's up? Um, but I am going to go ahead and jump into it here, guys. I think that, yeah, I told everybody that that was the way it was going to be from now on, and I plan on holding true to that. So, guys, please do me a favor. Hit the like button, hit the share. Please share this out if you would. I would really appreciate it. I am trying to grow the channel a little bit. I am, obviously that's always a goal, but we do kind of focus on it a little bit different during different times, and everybody has their own reasoning for trying to grow their channels. Me, I just want to get a bigger audience and be able to hey Marsha, good to see you, fellow Hoosier, for sure. I just like to, I really want to say that because I don't say it enough, I guess. Everybody else that runs channels, they always say those kinds of things, and I very seldom do. Maybe I've been doing myself a disservice. I don't know. But I would really appreciate if you guys could, share this out and, hit the like and do all the YouTube stuff. Hit the notification button. That way, because I am going to jump right into the space weather right away from now on. That way you're here quick and you won't miss anything instead of having to go back and rewatch it and all that. So that is exactly what we will do here. I see something that says VW emailed. I will check my emails. I haven't checked my emails here in a few, so we will check it. So, hey, what's up, brother? Tommy. All right, so we're going to jump into it. I'm not going to squirrel anymore. And just out of curiosity, I wonder how long I took to do that. Let's find out. About 2.5 minutes. Yeah, it's about 2 minutes too long. Sorry. So, let's just jump into it. Yeah, guys, solar X-ray flux. This is what we look at for solar flares. Nothing going, guys. There really hasn't been any solar flaring. As you can tell here, our proton flux is way down. That's what we look at for like radiation storms. And yeah, look at that. The base of that, that's very similar to what we usually see in like solar minimum type of signatures here. This is what we see usually during solar minimum. The base is just kind of low. What does that mean for us? Well, it just means we're going through a slow time. That's all that means. It's just there ain't a whole lot of activity. There's not a whole lot of sunspots on the front-facing part of the sun. Hey, Arizona. Linda, good to see you. Oh, yeah, sorry, guys. I keep doing that. That's a hard habit to break. But as we see those things kind of drop out, that, we oftentimes think that is, then we ain't got nothing to worry about. Well, guys, believe it or not, it's kind of the opposite. During times of weakened magnetic conditions, we definitely get hit a little harder. But when we're talking about like big massive events, believe it or not, if you really dive into the science of it, and I'm not going to get into details here tonight, and I might in the future, but when we got a better chance at taking a big hard hit during conditions you wouldn't think that would really be conducive to really hurting us pretty bad. So it's kind of opposite of what you would think. When we're active and all those kinds of things, yeah, we got a better chance of catching big ones. But when we're not active, okay, and then the sun fires a big one, because it happens. Just because we're in solar minimum, I've said this, guys, 100 times. The sun can do what it wants, when it wants, and how it wants to do it. And if it decides it wants to fire one off during solar minimum when we're not being already kind of being juiced up as far as our protection by the sun, right? The sun protects us from the sun by giving us geomagnetism, a certain amount of it. We got to have a balance. So when that balance is low and then the sun throws a real hard one at us, that's when you got to pay attention. Okay? Not to say that we can't take a huge bad hit also during a solar maximum. Because obviously during a solar maximum, there's going to be more flares and CMEs. Okay? So the chances of the sun firing a really, really like Carrington event level one is, 1859 Carrington event. You know, the one that fried telegraph lines, and you know, the handsets and stuff of the telegraph operators were catching on fire in their hands. Okay. And something else that I find really, really cool about that event is the fact that when that hit, you know, and all the electricity and stuff across the planet went down, you know what happened? There were still telegraphs being sent and received with no electricity going through the lines, not from any kind of source here on the planet. So there was enough of that in our atmosphere when we got hit. It was enough to let those things go on through. That's amazing to me. That was one of the coolest things about that event. Now, I have to say, back in 2017, guys, we had an X-class flare that did not hit us. Okay? It was on the backside, so we couldn't really judge exactly how big it was. So let me tell you right now that most people think, most scientists, mainstream, even though they say that that was probably bigger than a Carrington event level eruption. It just was not fired at us. We seen effects from it. We got a massive radiation storm. Hey, Fee, good to see you. I hope you're feeling better. Yeah. So, yeah, that happened. Fired a huge one off the backside, 2017, right? Keep that in mind, guys. So that wasn't too long ago. They say that was bigger than a Carrington level event. The Carrington level event, I believe, was an X39, I believe, solar flare. But again, you know, the flare can be that big, but you know, the CME can be whatever size that happens, right? So when we're talking about flares and judging flares, we're going simply off of X-ray. But the other stuff that happens, and believe it or not, guys, you know, not believe it or not, but this is actually the way it was. They really didn't differentiate between a solar flare and a coronal mass ejection until that Carrington level event. They were able to see that it was two separate events then. Okay, a lot of that had to do with the kind of equipment that we had at that point. We had some pretty decent knowledge then, some pretty decent telescopes. Obviously, there were no satellites up there. But, you know, we still had ground stations and some pretty good telescopes here on the planet. So we're going to go ahead and move on. Now, again, no flaring, nothing like that, but we do have a big coronal hole we're going to talk about right here. Gamma ray bursts, okay? I guess I could go right into that first thing. Let's just do that because it's on the thumbnail. Guys, this is spaceweather.com. If you guys don't know, I say these guys every show. Dr. Tony Phillips over here does a really good job. I've never talked to him. I don't know. I've never met him. I just think his website's awesome. I think it, and here's a link to it right there in the live chat. It's also in my description box. But we had a record-breaking gamma ray burst. Okay? It made currents flow here on Earth. And to give you guys an idea, this was billions of light years away. Let that sink in. They say it was from a supernova. Okay, I think if I'm correct here. I'm not going to read his article verbatim. Please go over here and check it out. Let's just see what it says here. I'm trying to find the number of how many billions. 2.4 billion light years away. Okay. We had a supernova 2.4 billion light years away, fired in the right direction, that it sent gamma rays. We got smacked with them. So this was very impressive, and it actually shocked a lot of the scientists. They were not expecting this whatsoever, which I don't see how you could expect something like this, but it took them by surprise, obviously. Now, I'm sure there's some precursors that they could probably look for, and they just missed them or didn't see them. But this changed a whole lot of things when this thing hit. And obviously things go back to normal, but during that time, things happen. It caused electrical currents to flow through the surface of our planet. All right, again, let that sink in. Hey, Ripper, let that sink in for 1 second here. Something exploded 2.4 billion light years. Not 2.4 billion years. 2.4 billion light years away. What does that mean? Well, you get yourself traveling at the speed of light, and then do that for a year. That's the distance you travel for 1 light year. Do that 2.4 billion times. That's how far away this thing was. So I don't think people really grasp how vast of an area we're talking about here. You almost cannot even understand it. It's such a great distance. Okay, so something like that exploded that far away, and we've seen effects from it as we're talking about it now. I'm not going to go too much more into that, but you guys please go over here and read this article. It'll give you a really good understanding of it. I'm not going to get into details here because I think it would be better if you guys read it yourself, to be honest with you. You'll get a better understanding. You can go over here and click on these little blue links. It will, they go into, if you really want to know the ins and outs of this, please click on that. So you'll be able to get a better, really good, if you're having trouble with some of the vocabulary words. Now listen, if you're having issues and you don't understand it at all, go ahead and email me. I'll try to help you, okay? As much as I can. So anyway, obviously, all quiet. They're even saying it here. Notice there's only 1, 2, 3, 4 sunspots even remotely looking at us right now. These over here really essentially are not. They're getting ready to rotate off completely, and we got one sitting right here. So, it's really gotten quiet. But the last time I said that, if you remember right, within like a day or two, we had like 8 or 9 of them. So remember that. Now, a sunspot is basically magnetic field lines on the sun. And because the equator of the sun rotates faster than what the poles do, and while I'm doing this, I'll just pull up STO here. How about that? That way I'll be able to show you better. So as I'm explaining this, the equator area of the sun actually rotates faster than the poles do. Okay, it's not a rock like we are here on our planet. This is plasma, right? So it can move at different speeds if it wants to without falling apart. And that's what happens. So when you start a sun cycle, these magnetic field lines are straight up and down vertical. Well, through time, because the equator of the sun spins faster, rotates faster, it takes these magnetic field lines that are vertical and actually starts doing this with them. See what I'm doing with my cursor here? And eventually, through time, it does one of these numbers, right? Then, before you know it, it's doing this. Okay? So they become almost horizontal. And when that happens, they get kinks in these magnetic field lines. And that's where all these charged particles are traveling, on these field lines, right? On the magnetic lines. So when you get those kinks, like if you took a rubber band and you pulled it, and you kind of twist it a little bit, what happens when you keep twisting it? It'll get a kink in the middle of it somewhere, right? And it kind of pokes up. Well, that's what kind of happens with these sunspots. There'll be the magnetic field lines with all this energy traveling on those lines, and when those kinks happen, they poke through the surface of the sun. And lo and behold, what do you get? You get a sunspot. That's how it's a very basic way of explaining to you guys just the basic production of a sunspot. So, and there's obviously there's a whole lot of science behind that I'm not going to get into. So, yeah. Now, so with that being said, yeah, no sunspots going on, guys. I mean, we just really don't have a whole lot. Now, this is the HP. This is the 30-minute. This right here, I've been showing you guys this. I'm going to explain it again here. This is the KP. These are 3-hour data points, right? Every 3 hours, it'll put one of these bars on here. All right. Well, this one does it every 30 minutes. So this one, definitely, in my opinion, is just better. For that reason, they're both global readings. Okay, they're not regional or specific local, so they both work the same. This is a German site. I watched Tam at the Scove actually talk about this. I didn't know this thing existed until like 2 or 3 weeks ago. So it's been very beneficial for me, and I hope it helps you guys understand things a little bit better also. But as you're looking here, so you can see down through the days here, how we were kind of a little bit more active back here. We had that surprise geomagnetic storm back here, but it only lasted like 15 minutes. How could we know it only lasted 15 minutes? Well, because look, now we get a reading every 30 minutes instead of every 3 hours. See, before I could just say, well, we had something happen in that 3-hour time frame. Now I can say, hey, we had it happen in this 30-minute time frame. So it's a little bit more specific. Man, I tell you what, Tommy, I'm just going to say this one time and one time only. That same website there, guys, that you guys have seen there, I just deleted it and banned it. That same one's been hitting here and on my second channel, me and Tommy's second channel over on Tommy and I should say. The Lifeboat, this channel here. Okay, we've been getting smacked with that stupid porn site. It's been happening a lot. But you know what? You know what that means? It means we're in the big leagues, baby. Just kidding. But no, that actually is kind of what it means. That means they're not going to come here and waste their time on a channel that's only got 10 viewers or something stupid. So that's, as you get bigger, that happens. So anyway. Yeah, Rue, I hope I explained that a little bit. It's hard to explain to somebody how a sunspot is formed. Okay? It really truly is. So, if anybody understood what I said or if they have questions, guys, listen. If you don't know who Tam at the Scove is, please go over there. I left a link. I think it's in my description box now. She does this. It's free college. I mean, honestly. So go over and check it out. She's got full shows explaining that. So, hey, Ilea, good to see you. Hey, by the way, guys, I got a pink hat from my Ilea, a pink boggin with a light on it. It's awesome. By the way, you can charge the light that's on it with the USB. I won it over there. She does the game show on her channel. That's what her channel is. It's a survival game show. So she sent me that hat. Thank you, Ilea, by the way. It was awesome. I sent her a picture of it on my I got a little baby Yoda. And I put it, well, it's Grogu, the guy from Star Wars, little munchkin from Star Wars, Mandalorian. It's a baby Yoda. So I put the hat on it and I snapped a picture. Pretty crazy, but I is what it is. So, thank you though, Ilea. It's cool. My wife liked it too a lot. She probably confiscated it from me. If not, my daughter will. So let me talk about the solar tornadoes I was telling you guys about in the thumbnail. We've been seeing quite a bit of these, and all that means is we're having activity. We've got. And what is the solar tornado? A lot of you guys probably don't even know. What I'm gonna do is I'll just push play. Watch right here. This is the 193 angstrom. Okay, and so you see that kind of spinning, right? What's that look like? I mean, obviously it looks like a tornado, right? But it's not in the sense that you think. Okay, and I'll explain a little bit more here in just a minute. But this is the 193 angstrom. This is on a satellite called SDO, And I should have taken you guys to show you where it's at. But I showed you guys yesterday or the day before in my video. If you want to know exactly where this satellite is, it's from our perspective, okay? It sits out in front of our planet. It rotates with us, and it also orbits the sun with us, obviously. Stays over the same spot of our planet at all times, but it always keeps its eye on the sun. Okay? So it's a view from what it's as if you walked outside and looked up at the sun. Okay? Essentially. Obviously, I mean, it's not exact, but it's close. So yeah, so you can see this, right? And this is a really good way for me to explain, you know, these lines of connectivity that I talk about all the time. These magnetic connection lines. What you're seeing here, guys, that is not wind moving in a circle or in a vortex. See how these things are stretched across? Those are magnetic lines connecting to the sun's surface. What you're seeing in the movement is those lines moving. And then what you're seeing as far as the dark shadow part is actual plasma moving on the line. Okay, up and down, back and forth, depending on the polarity. You know, if you were looking at this in the heart of Tornado Alley, what would you think? You'd be sitting there thinking, oh my gosh, look at that multi-vortice tornado. You know, you got this big, huge tornado. It's got 12, 13 different little sisters just rotating all around, right? Well, it's not wind, guys. That's plasma moving very fastly, by the way. If you were to stack Earths right here, you could probably stack it up, I don't know, probably 5 or 6 Earths tall here, maybe even 10. That's how big that thing is. But you can see how it started in this big, wide area. It's almost like I almost called it like a solar hurricane. But they don't use that term, so I didn't. But you can see how it, you know, I just thought this one was really interesting. What's up with Marf? Something going on with Marf I haven't heard. I'll do that, drop a deuce number 2. That's a good idea. Wow, I didn't even think about that. I can't believe I haven't thought about that. We just usually block them. Wow, that's I do got words set up that they can't post if he's not feeling good. So okay, is he having his normal his bowel stuff that he has going on? Ilea, prayers for him for sure, guys. Be praying for Marv. It's miserable for him sometimes, guys. He's got some serious issues when it comes to that, and it hurts. So yeah. But anyway, guys, back to this. You can see that, guy. I just thought this was cool. Okay. Thank you. But no, so what we're going to do here is actually we can go up here. I'm going to zoom back out so we can get a little bit better of a look here. And you notice how this one does kind of show the solar vortices. That's what they call them, solar vortexes. Or they call them, you can call them a solar tornado. I mean, everybody uses both terms kind of intermittently there. But they're happening on a lot of different places on the sun right now. They're probably happening right over top of us right here, right in front of us. We just can't see them because the sun's the background. We get to see them when they're kind of over here on the edge. So you can see this one's kind of doing it. This is a filament. Now this one was erupting. See that? I'll zoom into that one for a little bit. You can see the corona kind of get disrupted because there was an eruption there. It's not coming at us. That's why I'm not even going to waste any time on it. But watch what happens. This is a filament. And this is that big sunspot over here, guys. Remember the one we just got through getting rid of here? So watch this kind of stand up. Same thing's happening. You see all the spinning? Okay? I know it looks like wind, and it's hard for us to understand that that's not wind. You know, when we're here on our planet and wind happens, it's low and high pressure moving to fill in each other's space. Okay? Up and down. Low and high pressure. It rushes in. They follow one another. Right? So that causes wind. What's wind? Well, it's all the molecules in the atmosphere because of that pressure moving. We feel it because it's friction. We can't see it because it's so small, but we feel it. Now, this is different. This is magnetism and charged particles. Plasma is charged gas. Okay? So that's why it has to travel on these magnetic lines. In case you guys didn't know, some people don't know this, but plasma is the yeah, somebody's in here doing that on purpose. Just so you guys know, I have to say, when that happens like that, there's specifically, and here's the thing, guys, that porn site there, it's been on over on the lifeboat and here, so it's somebody that doesn't like me and Tommy. I guarantee it. That's okay. I think it's funny that they're wasting their time with that. To be honest with you, we're in their heads so much that they have to do that. It's kind of crazy. Anyway, so as you're looking at this, I think it's hysterical. By the way, I think it's funny as crap. I laugh at it. So you got these things standing up here, right? And it happens. See it all spinning? It's just not wind. Yeah, report those things, guys, if you would. If you report them, they will get them out of here. So, but anyway, guys, yeah, so that's just another way to show you guys that that's what's happening on the sun. And that's why this thing, guys, this you're looking at right here, the main controller of our weather. Not just local, not just, you know, a rainstorm here, a rainstorm here, there. Climatological. And yeah. And Earth is only the size of your mute. Gotcha. Thank you, Arizona. I appreciate you for sure. Yeah, most of them are bots, Anna, but there are people out there that do that. They'll fly them in here. I promise you. Matter of fact, I know somebody that used to actually do that to some other people, and I quickly got away from that person. I'm not going to go into who that is. You guys might not even know him, but yeah. So I know that they can actually do that. It's stupid, but it happens. But yeah, butt heads, exactly. Regardless, we just don't want it here. Yeah, thank you, Mary. It does. Guys, when you guys do report that, they do look, you know, if you get enough of that, they will look at it. The algorithm will hit it, and then if enough of it hits, they will send it off to a human to take a look at. But it does take a lot to get that to happen. When you got, what, 56 million YouTube channels, close to 57, I think, at this point. Yeah, it'd be ridiculous to think that a human could look at everything. There's no way. It's just too big. Anyway, this coronal hole, that's what's going to be giving us our space weather. Watch how this thing just forms. Check this out. You know, see it's kind of getting a little bit dark here now. Now watch it just like the corona just opens up as it rotates in. You're watching it form right in front of you right there. Okay? Now remember, that's not a hole in the sun. That's a hole in the corona, the atmosphere. The black is the actual surface of the sun. Okay? And when the corona opens up like that, it allows charged particles to flow out. So yeah, it's yeah, for sure. Yeah, I don't either. I don't. That's something I don't even like to know either, Anna. 100%. I will not. I knew somebody that was doing that, and I was like, no. This was like, oh God, it was like 5-6 years ago. I don't even think I had my channel yet. I just knew somebody that did that, and I was like, man, why you gotta do that? It's just stupid. They do it for no other reason, just that they think they're having fun doing it. They think it's funny when it happens. They wouldn't think it's funny if one of their daughters or sons was watching some other stupid, like a child show, and it popped on there like that, and their kid would click on it. They sure as heck wouldn't think it was funny then, would they? That's the kind of stuff that bothers me. We're adults. We can handle that kind of crap. Who cares, right? But the problem is the kids. That, for me anyway. You know, I try to protect my kids as much as I can, but I have to say, you know, when all that happened with my daughter and that dude sent a bunch of pics to her and of all the disgusting things you could possibly think of, when that all happened, I took a really good lesson from the cop I talked to. You know, he's like, listen, you got to teach them how to use the internet the right way, and that's true. We can do our best to try to protect them, but the fact of the matter is we can't protect them from all of it. So you better be teaching your kids how to navigate the internet the correct way, and how not to get to those places. So anyway, sorry. Come on, guys, you got to throw the squirrels in the chat when I'm doing that. I'm going to try not to do that. Okay, so we're over here at LASCO C2. So let me back this up. This is seeds. Our planet's here. The satellite I'm getting ready to show you sits right out in front of our planet looking at the sun. This is SOHO. So if we take a look at the 18th, watch what happens there. Obviously, people are going to see that, and they're going to be like, oh my God, what is that? Well, it's not a whole lot of nothing, really. You see that? I know it looks like it's a big, huge eruption. I don't think it is. If it is, it's going off the backside. Okay? Hey, Pamela. So that happens right there. So what that is typically the camera's gotten flooded with light. There was probably an X-ray burst on the sun that was bright enough that it made it around the occulter disc enough that the camera couldn't handle all the light. Or they were moving the camera a little bit. Seriously, when you change the angle like that, sometimes more light gets in. So yeah, Anna, I haven't talked to Scott in a while. Last I heard, he was doing fine. I know Dr. Albers was fighting some stuff there too with her the silver poisoning and all that. Or was it mercury? I think it was mercury poisoning from her teeth. But yeah, I know she went to Florida and had some procedures done with bone marrow, I believe. But yeah, and I think she came back and was getting better, then started getting worse again or something. But I haven't talked to Scott in a minute. I know he was making videos again there for a minute, and then hasn't made any in a while. But yeah, definitely prayers for them. Okay, anybody? Yeah, send them some prayers, guys. That's no fun. Okay. But yeah, as far as I know, as far as like big things and stuff, things are probably okay. Haven't heard anything other than that. So, but anyway, guys, you see this? It's erupting, right? There was an eruption here. Is it going off the backside? Yes, I think it is. And that was probably the one you're seeing here. Watch. It'll happen right here. We'll take a look at it here again. Come on, hurry up. See that right there? There. And there was one down here too. But both of them are going away from us. None of it's coming at us. This is what we got to be paying attention to right now. This coronal hole, it's going to be sending, charged particles our way. So this is what we're going to have to look for, I think within, because we're going to connect to this thing. Actually, I'm going to pause it, bring this back up to current. We're probably getting ready to connect to it now, if we haven't already. So, yeah. Once we connect to this, depending on how long it stays in front of us, it is substantial, okay? Remember, we got the parallax effect. Things that are on a sphere, when you're looking at a sphere, when they're on the side, they're smaller than what they actually are. They appear to be smaller. So when they get right in front, they appear like they grow. Sometimes they do grow when we're looking at the sun, but if there was a hole, say the size of a quarter over here, by the time they got over here, if it stayed the size of a quarter, it would look more like a $50. Okay? So that's kind of a good way to kind of understand what's going on with the parallax effect. Most of us understand that. I just explain it that way because some people don't. Some people don't understand that. Doesn't make you stupid either. Okay? Just makes you just don't know that. Or you forgot it from high school. So, just the way that it is. It kills me because some people look at these kinds of things and they'll apply it to what their theory is or whatever. And usually the theory is like really, really way out there, right? But they forget that it can be disproven from like 8th grade science. It blows my mind, some of the stuff. And speaking about that, we're going to be having Tommy on the show. Been asking him. He's got a Gosh dang, I'm drawing a blank on what that thing is called. Yeah, come on, Tommy, throw it in there, man. Let me know what that is. Forget what they call that. It's for navigating on the sea without technology. Oh my God, what is that called? I can't believe I'm drawing a blank on that. Come on, dude, throw it in there, man. I need to hear it. Need to hear it. It's driving me nuts. Anybody else know? Yep, there you go. Thank you, Fee. Thank you. Sextant. Sorry. Thank you, Menacing. Now everybody's going to be saying it, right? No, not a compass. But yeah, a sextant. Yeah, it's a tool that mariners used to use way back in they still use them when their technology goes out. Guess what? I'm going to say it right now that if things in the sky were not almost exactly where they used to be hundreds of years ago, you could not use a sextant and get it to work. You would be lost. Okay? Let that sink in for a minute. All right? There's certain things that are up there that you can look at and get angles off of. There's something else to something here too. Do you guys know where the first mass use of the word computer was used? You guys know this? I'm not sure if you guys do. You probably don't. Most people don't know this. That's what they called women and children in Greenwich, England, that would actually compute locations of stars on a specific day and time. Okay, why did they do that? Well, if they knew what the sky looked like in Greenwich, England, at any specific time, if they were on a boat where they couldn't see a horizon, or they couldn't see any land, and they looked up, and they could find the same stars, but they were in a slightly different location, guess what? They can refer back to that number that those computers had written down in Greenwich, England. So when you compare the two angles, you can figure out your position as far as longitude, latitude on the planet. Okay? So that was one of the main fears mariners had way back in the day. They had to keep land in eyesight. If they did not, they could get lost very easily. They could be sailing to wherever they're sailing to, and if you're off 1 or 2 degrees, by the time you're 100, 200 miles out, if you're off 1 to 2 degrees, now you're off 30 or 40 by the time you're trying to get to where you're going. You've completely missed it, and now you're out in the middle of the sea, nowhere to go. So what I'm saying here, guys, is if things had changed, the sextants would not work today. Sundials. I'll just say it right now, too. Sundials. Simple sundial. How do sundials work? They work off shadows, right? How do shadows work? Off the position of the sun, right? So the axial tilt of the earth matters. That's how the shadow changes throughout the year. The axis of the earth, this imaginary line that we rotate around, right, always points in the same direction no matter what side of the sun you're on. So if it's pointing to the left when we're over here, it's pointing this direction, right? Guess what? When it's over here, it's pointing the same direction. So that means that we're getting more direct sunlight in the summer and then in the winter. That's how our seasons are made, guys. So if that had changed in any significant way, none of that would work. Especially if you're talking about going from where we're at 23.4 degrees. I think that's what our axial tilt is. Because what I'm talking about here, guys, you got the ecliptic of the sun. That's the equator of the sun, basically. If it's an imaginary line at the equator of the sun, if you extended it out infinitely, that's the ecliptic of the sun. When you hear somebody say the Earth is north of the ecliptic, that means that we're a little bit north of the center of the sun. When you hear somebody say the Earth is a little bit south of the ecliptic, because we do, we kind of go up and down as we orbit the Earth, orbit the sun. It changes a little bit. There's a lot of things that would have to be explained if our axial tilt had changed drastically. And this is one of them, sundials. I don't have to use any technology whatsoever. Yeah, Kathleen, the Earth is wobbling, but do you know what Earth wobble is? And do you know how much it's moving? We're talking micro degrees. And it's a natural movement. Okay? Earth wobble, say the axis was up here, right? Let's say the North Star is here where my cursor is. You know what? Hold on just a minute. I'm just going to do this. Hold on 1 second here. Come on. Pop in here. Okay, so let me do this real quick. It's not going to let me pull that in, I don't think. Daggone it. It's not. Shoot. Okay, hold on 1 second. I think I could change it. But, you know what? Let's see. Hold on 1 second, guys. Sorry. I want to see what you guys are seeing here. Let me do this. That'll work, I think. Okay. I think this is going to work. All right. You guys got that, right? That's paint. You guys got paint right there, right? Am I correct? Somebody let me know. We're going to spend a little bit of time on this right now. All the space weather reporting's over. Okay, so if you guys are out on that, cool. But I'm going to show you some stuff here real quick. Okay. So you guys got that, right? I'm going to use very, very just basic shapes here. Okay. So I'll use a, I guess, a circle. This is the sun. Okay. I guess I could have made it yellow. I should be able to change the color of that. I'm sure I can. Well, just put the sun here. Anyway, we're going to do it like that, okay? So, we got that, right? That's the sun. Tell you what we could do is just do this. This would probably be better so you guys can understand it more. You know what? I might have... I kind of do right here. Huh. Let's bring that up here real quick. Yeah, you're right. We did. So, I know that this is showing you the South Atlantic anomaly. Okay, this is why I had this up here. This is a geographic axis. I put that up here. This is the magnetic axis. So I hope you guys know what that is, right? We have a geographic North Pole. So when I'm speaking to you right now, I'm talking about the geographic North Pole. I'm not talking about our magnetic north and south. Okay? So please understand that. I don't want to like confuse anybody on any of that. So So let me do this real quick. And so what I'm going to do, just pay attention to this red line, okay? That is always pointing the same direction. No matter what side of the sun you're on, it is always pointing at 23.4 degrees. When Earth wobble, when you're talking about Earth wobble, the point of this is moving just a little bit. Okay, one way or the other. Now, I'll show you here in a minute exactly how much it's moving. It's not moving hardly any at all, but it is wobbling enough that our North Star will change. And we know this. This is a known fact. This is not something that's new. This is something that's always been known since we've been able to do these kinds of things. Okay? So with Polaris up here, right? Eventually with the Earth wobble, that means the axis of the Earth is going to be pointing at something different. So we won't be able to use Polaris. We'll have to use a different star. And I forget what they call that one, but they already know which one it's going to be. All right? And it's not that much movement, guys, okay? We're not talking from moving it from like here, right, to the axis way over here. That's like a 40-degree change, right? Everything on this planet would change. Everything would change. You would not live through that, most likely, just so you know. Okay? So if we are at, as a matter of fact, I'm going to pull this so you guys understand that, all right? This is our axis. I'm going to actually start a new project here and just show you, because it's just easier if you guys see me build it, because it definitely will help you understand. So I'm going to do a 3D shape here, and we're just going to do it this way. Okay. I think I could change the color of that. Let's see here. Undo, redo, paste, copy, delete. I probably should have just changed it. Yeah, here it is. Edit the color. There we go. There's your sun. How about that? You guys like that? I can actually make it bigger too. How about that? There we go. All right. So that's the sun. Let me make the earth. All right. Thank you, Angel. Appreciate you. So here's the earth. All right. Guess what? I could even make a straight line. You guys believe that? So if I take that and we go, oop, don't want to do that. That was stupid. I don't use this very much, just so you know. Actually, I'll go here and use a 2D shape, and we'll do it like this. Okay? So the axis of the Earth. Oh, okay, there we go. What's it doing there? It's wrapping around that thing. Well, this will work for what I'm trying to show you. Okay, so that's at roughly 23. We'll just call it 24 degrees, just for the sake of argument. All right? As we orbit around the sun, this stays pointed that direction. Okay? This always points this direction. So when it's here, it's there. So let me do this and watch this. I think I can make a copy of this. Oh, it moved it. Actually, I'll just put that there like that. That's better. I guess I can just make another one. How about that? Let's just do that. No, that's 2D shape. I don't want that. All right, go back to 3D. I don't know why it's on that for. Oh, there we go. Right there. So, go over here. Make another one for you guys. Okay? So, with that being, that's exactly the same, pretty much. It's not going to be exact, but it's going to be close enough. 2D shapes. We'll go back to a straight line here. We'll put this one here, just like we did the other one. Oops. Roughly the same. Okay, so if I put that there, and if I come back here and I click on that, oops. Boy, if I just didn't jack that all up. Let's just make it smaller. How about that? Okay, you guys get it, right? Right like that. I'll just do it like that. I think I might be able to click on, yeah, I'll just move this one out of the way. All right, so, and I can delete that one. How about that? There we go. We got it. We got it. Close enough. So you guys see this, right? We're always pointed the same direction. That's what gives us our seasons, guys. So, what would happen? See, we rotate on this thing, right? On this axis. That's what we rotate on. So, if you're standing, what color I got here? Come on, give me something here, people. It's a marker. Here's the thickness. Come on, give me something here. Let's go yellow. That's too big. Let's bring the thickness down a little bit. So, we're at 8 right there. Say we're right here, standing right there. You see that? We're rotating this way, right? Rotating around. So, at any given time during that day, right here, you are on this line. Right? So, the sun's here. What happens if you take this axis and you pull it down here? That means you move too, right? If this got pulled down, you move down here. Guess what? The amount of daylight hours you would see would change in a drastic way. Because there's something called the midnight sun and what else they call it with the 24 hours of daylight, right? You got hotels, you got tourist locations that operate off of that. There are places on the planet inside the Arctic and Antarctic Circle that you can go and you will see the sun stays up, never goes down. Okay, this is common, simple knowledge. So, if our axis was moved any significant amount, we're talking 5 degrees, especially in some of the stuff that people are talking about, like an extra 40 degrees or 60 degrees down. Like, say we went from here and we moved that far. Guess what? Now you had 24 hours of daylight today. Well, if that axis moved down, guess what? You don't get to see the sun at all tomorrow because you moved so far. Because now you're down here. Does that make any sense? I hope it does, because this is something that is just, I don't understand how, if we had moved that far, all these things would have to be changed. Now listen to what I'm saying here. If you woke up, how long have we used Polaris, number 1, as the North Star? Does anybody know? I don't know. It's been a very long time, I can tell you that. Let me look it up just real quick, and I'll let you guys know, okay? I'm going to do a quick Google search. How long has Polaris been the North Star? Listen, guys, listen to what I'm saying here, okay? In 3000 BC, a faint star called Thoban, or whatever it is, constellation of Draco, was the North Star. Polaris did not become the North Star until about 500 AD. You guys know how long that was ago, right? 500 AD would put that 1500 years ago. Polaris has been our North Star for 1500 years. It still is our North Star. Polaris could not be our North Star if our axis had changed. The fact that we have Earth wobble proves that. Okay? We have Earth wobble, so it proves that our North Star has to change. Right? Well, it hasn't. We're still using Polaris. No satellites involved. No technology involved here. This is simple. Go outside and look up. Honestly. So we're using Polaris. It's up here, right? Let me pick a different color. Let's pick red. Polaris is up here. Okay? Right above our North Pole. What happens if our North Pole oops, hold on. What happens? Yeah, this is being a butt, by the way. I don't know why, but it is. Hold on. Yeah, see, I can move the ball there too. It's Paint 3D. Sorry. It makes it a little bit more difficult when you're combining 3D and 2D imaging. So I'll leave it like that. Okay. What happens if we move just that far? That's probably what do you say, 20, 30 degrees? And some people are talking we move 60. So if our axis, if we're pointed at Polaris right now, and I just told you guys that Polaris, we're still using it. They were using it 1,500 years ago. We know it's going to change because the Earth does wobble a little bit. The axis does. So, if, say we moved 30 degrees just drastically, something yanked us on our side like that, what would happen? What would happen? Now, Polaris isn't over here. Everybody would be completely lost. Not to mention now, if you're standing here and you move that far, well, you got to move yourself down here. So now you're having a different amount of hours of daylight. You get what I'm saying here, guys? We would have to have a star out here we would have to pick to be our North Pole, northern star. None of that can be explained. If you're going to say that we tilted like that far, you have to tell me why that didn't move. And I just proved to you without any technology at all, period, nothing, because I showed you guys that 1,500 years ago, we were using Polaris as our North Star, and we still do today. So that would have to be explained. And it can't be. It just can't. You're exactly right, SG. I haven't gotten into those details because I didn't plan on doing this tonight. I got all those details. I'm just not going to get into it. And some of the theories are saying that we went down to the 90 degrees. If we went to 90 degrees, you would have 6 months of daylight and 6 months of darkness. 6 months out of the year, you would never see the sun go down. You would burn up. And then the other 6 months, you would freeze to death. Because our axis does not orbit the sun, does not rotate as we orbit the sun. It always points the same direction. So if it's pointing here, when it gets over here, it's pointing the same direction. That's what gives us our seasons, precession. Exactly. None of that can be explained. We used sundials thousands of years ago that are still there. Hasn't moved. Guess what? The sundials still work. Yeah, Menacing, you're right. I've moved a little bit past the old broken phone days, right? And yeah, so what I'm saying here, guys, is Tommy's going to come on. He's going to show us how to use the sextant. Okay? And that's going to show you guys that you can still use the stars to navigate without technology. What's that going to show to you? They use the same stars and the same maps and everything else. Pickle on a stick. Yeah. Not even going there right now, brother. Anyway, so when that's happening, yeah. So if you can use a sextant right now and it works, guess what? That means that the same sextant that they used, hundreds of years ago, worked the same exact way, would not work today if any of these things changed in a drastic way. You also do not have to use that. You don't have to use the sea. You can use a sextant on land too, but you won't. It would be very, very hard for lots of different reasons. But there's other ways to navigate using the sky when you're on land. None of which would work if the axis of the earth changed that drastically. None of that stuff would work. Everything in the sky would be in a different place. The people that run these tourist locations for 24 hours of daylight, 24 hours of sunlight, they could no longer operate. You can go back and look at pictures from 30, 40 years ago from these places. Same brochures, same latitude, all the above, right? Nothing's changed there. They're still experiencing the same conditions. And if we had moved that much, it would change. None of that can be explained. None of it. None of the sundials that we had on this planet thousands of years ago that are still there today would work. None of them would work if our axis had changed in a drastic way, because it's based off of shadow. And what's the shadow based off of? How direct we're pointed at the sun. That's what determines how long your shadow is, guys. That's why when the sun is at 12 noon, when you're on the equinox, that's why you don't see much of a shadow, because you're directly pointed at the sun. What's that mean? That means if anything had changed at noon, you would not be seeing the sun like that. All of it would be different. Every single bit of it. Every single bit of it would be different. Everything would change. You can go look at all the data and stuff. If we, if we tilt it to 90 degrees, right? Remember, like I said, we got the ecliptic of the sun, right? So 90 degrees would put us on that ecliptic. So that means as we're rotating, we're not moving. The shadow, the termination line, would not change, because it would always be in the same place. It would be perpendicular. See how this is? I know this isn't really good thing here, but that's perpendicular, right? This is a right angle. I know it doesn't look like a right angle, but perpendicular, that's right angle, right? So if we're perpendicular, you would get like, it was basically you're spinning straight up and down, and you would have the exact same seasons all year around. Okay? But if you're horizontal to this, if you're on the ecliptic, rotating on that line, what's that mean? You're rotating this way, up and down, right? If you're on this horizontal line. That means that your view never changes. That means the shadow never changes. That means the backside, back here, would be dark for 6 months until it got over here, and then it would be light for 6 months. So for 6 months out of the year, you would be burning up. You would just die. And then the other 6 months, you wouldn't have to worry about burying yourself, because you'd be frozen in a block of ice. Just saying. So 90 degrees is, you can go look at any kind of data or anything. It is impossible for life to live in those conditions. I'm not just talking about us. I'm talking about down to plankton level. I'm talking, this is planet killer type of stuff. Okay? This is big stuff if we move that far. It just didn't. Okay? Just saying. But anyway. Yeah. And again, these are just things that, would have to be explained. They would have to be explained. And again, here's the other thing too, guys. I don't have to explain any of this. I'm not actually questioning what's accepted science, that we're at 23.4 or 24 degrees tilt, right? I'm not the one saying that we're any different than that. It's not up to me to prove that that's correct. And it's also not up to me to disprove what others are saying. What other people say, they have to prove it themselves. How do they prove it? By explaining why these things are the way that they are. If you can't explain these simple things, then it doesn't work. It just simply doesn't. It doesn't work. And I don't know what else to say. I really don't. On that. But we're going to get Tommy on here, and he's going to show us how to use that sextant, because that's somebody that knows what he's talking about when it comes to that, navigating by the sky using a sextant. Okay, so we'll get Tommy on here. He's going to show you guys how to do that. Hopefully you guys will go over and sub up to hold on one second here, guys. Hopefully you guys will go over here and sub up to the lifeboat. I've been trying to get everybody over there anyway. It's Tommy and I's second channel. We talk about addiction recovery, all those kinds of things. I'll leave a link here in the chat. But this is, Tommy knows what he's talking about when it comes to sex and stuff. He pretty much, he's known how to do it. So what I'm saying is he's going to come on and show us how to do it. And that's going to show you guys that, it'll help you guys even understand more that if things had moved in the sky, that none of it would work. It's really seriously that simple. And it can't be explained, right? If you can't explain why that still works, then there's nothing else left to talk about. Really, honestly. And it's not just one thing. We're talking 3 or 4 different things here. The sextant, the sundials, the fact that we still see the same 24-hour hours of daylight in the same parts of the planet, all of that. None of that can be explained if we tilted that far, because none of that would work. It's impossible, guys. Simply impossible. And if you're going to say that those things would still work, well, you're going to have to show me how it would. And don't just tell me to go outside and look. You better bring some math and show me what's going on. Because it's just, you can't. Anna, be careful. Oh my God. But yeah. Space weather. I was on Space Weather Tutor. I was talking about space weather the whole time. We was talking about space and how our axis of the Earth and all that. Just saying. But little quick rundown, guys. Yeah, so nothing much going on as far as space weather goes, as far as what we got to look at as tomorrow or the next day. We do have this coronal hole right here. That's going to be sending us some some solar wind, and that'll be here in the next 2 or 3, probably 4 days, I would say. This could put us into geomagnetic storm conditions, depending upon how our angle is. And what is our angle? The angle of our magnetic field. And that would be, trying to get back to it here. Where the heck did my Discover data go? Did I X out of that? I sure did. I think, nope, there it is. The BZ. The BZ here is the angle of our magnetic field. When it's in a southerly declination, when it's pointing towards the south, that means that when it gets to -6, when that angle gets down that far, that allows space weather in easier. So if it gets to -6 and we get an impact from an increased solar wind stream, then that's what we're going to have to be looking at. Okay, we could be looking at some geomagnetic storm levels. Just saying. But there was an eruption. This eruption is off the backside. This is not coming at us. I wanted to show that to you real quick. And again, guys, solar tornadoes right there. Go check them out, guys. I guess I can zoom in here a little bit more. And we'll play that. We'll just let that. Oh, let me zoom out. I'll play it. You guys can see the solar tornadoes here. And yeah, so I just think that's cool how that works. The backside eruption is actually going away from us, so it's not. We're not going to get any kind of impacts from that. We should not anyway. There's always a chance it could come back to the interplanetary magnetic field, and we kind of catch a sideways blow depending on the angle of it. But it is what it is. And earthquakes, guys. Pay attention to earthquakes. I'm not going to get into that discussion tonight. So yeah. Trying to figure out if I missed anything here. But yeah. So let's go ahead and do one. And we will skip that ad. Pause that. This is us, guys. So please come over here. We talk loser. Time to get past it and realize who you are, who you really are after addiction. Guys, we're not losers. But you can be. So, just saying. We gotta, if you guys know anybody that's fighting addiction, if you know anybody that, if you yourself are, please come over here. Most of you guys know this. But this is Captain Tommy. He's going to come over and show us how to use the sextant on Wages World. So do us a favor. Do Tommy a favor. Come over here. Sub up to this channel. Bring everybody you know. Because everybody can benefit from understanding what drug addiction is. Because if you don't already know somebody that's in this, I promise you, you will very, very soon. Because it is a complete epidemic. And we don't judge people here. We want people here that are, currently using and all those kinds of things, or alcoholics. We help people, guys. Okay? Nobody judges you over here. We love you guys. And you'll see that right away. So, but anyway, I am going to go ahead and pop off here. We are going to, we're just going to kind of kill this one here. Because I've been going for an hour and 13 minutes. Oh my God, I can't believe that. Wow. Yeah. Please share this one out if you could. And we'll roll with it. So, guys, here you go. I'm going to hit that. There's another link for the lifeboat. Please come give us some love over here, guys. I really appreciate you guys. Back at you, Tommy. And again, guys, you'll get to meet Tommy here on the channel here before too long. Back at you, Greta. Peace out, peeps. SG. Julie. Good to see you guys, I'm not even going to comment. Not even commenting on that one. Yeah, we did pick up a 13th sign. You're 100% right. And see, this is my point, guys. We do know that those things are going to happen. Right? So if we can say that they're going to happen on this time frame, what does that mean? That means we're actually predicting things, right? Back at you, Mark J. I'm not sure if that's my son or not. Mark J, what are you doing? I don't think it is, but I'll tell you what, I'm going to go to the channel here and look at it. We're going to look at Mark J's channel for a second. You got a channel, Mark J? That's who I thought. Yeah, okay. For real. Cool. Cool. For sure. Go check him out. Here's his channel. Go give him a sub. Not sure if he's making videos or not. Looks like, nope, he's not. So, anyway, maybe he is. Let's look. Oh, maybe he is. Last one he made was a year ago, so he might have been taking a break here. So, he may not want the traffic. I don't know. But that's Mark. Sorry, Mark J, if I caused you some issue there. Didn't mean to. Hey, Renee, good to see you. Pamela, what's up? What's up, Occam's Razor? Back at you, Drop a Deuce. I like that name, by the way. I know it's a little edgy or what have you, but it is what it is. Yeah. Anyway, I am going to go ahead and bolt off. Come give us some love over here. Come give me some love here. We're going to get Tommy over on the channel here to explain how to use the sextant and why that even matters. Go check out Rip Marfugel. Prayers for Marf. Prayers for Marf, please. And anybody else that's sick, please, guys, go show them some love. So, anyway, guys, God bless. Here's that coronal hole right there. Solar tornado right there. Yahusha saves. And as always, what? What can you guys drink? You can always drink this Kool-Aid, all right? All right? Roll that sun back and forth. Prayers for Mark. For me? What you got, Mark J? You got something going on, bud, before I kick off here? Are you okay? Did I miss something? Oh, Marv. Okay, yes. Seriously, prayers for Marv. Sorry. Yes, for sure. Yes, please. Please, guys. He's not feeling well. He does suffer with that, bowel issues. So I'm not sure if that's what's going on here, but I'm going to try to find out. So anyway, guys, God bless. Yahusha saves. You can always drink